In our project called Collabmath, we've combined the power of a wiki, GeoGebra, a very powerful online web-based mathematics tool, and screen capture and casting through, in our case, Screencast.com, to create an environment for senior secondary, college, and university students to interact and share mathematical ideas and collaboratively in groups build towards solutions to problems. We've used PBWorks Wiki as our site, but we've tested it on other wikis and it works there also. We've taken this approach to combine these three tools because of their potential to support student collaboration, and student collaboration which is free and to the student in terms of they set the direction. A wiki, if you give students full permission, students can create their own pages and link them together, and therefore they can take the discussion off or the work off in the directions that they see are the correct ones and viable, and can have multiple branches in their discussion. GeoGebra supports the student work in mathematics, allows them to experiment with things and investigate things. There's this dynamic mathematics program, but in our case, another very important feature is that students can pass on their work to someone else by posting an applet as they leave the GeoGebra program, capturing an applet and posting it to the wiki site. The web is not particularly conducive for communication of mathematics through text. It's difficult to construct correct mathematical symbols and expressions and such in the web, so in most web-based editors. So allowing students to record their own voice and their work in GeoGebra from the screen and then post these videos up, share the videos, allows them to communicate their ideas in a much more natural and relatively simpler fashion. Let's look at an example. The idea is that a teacher would present a problem, probably in the form of a video, to get started, and that's what I've done right here.
I have a problem that I would like you to work on in your groups. When we walk towards someone holding a flashlight, the light gets brighter or more intense. We're going to work on this problem and build a mathematical or a function model for this situation.
So the teacher has presented the problem situation in that form, but also below here has presented a GeoGebra applet which has the data, the distance and intensity measurements. And what's powerful about this is that this in fact is live. If a student clicks on this, they're able to manipulate it and do some work with it. And that's in fact what is done here. Bob has made a contribution, the first contribution in his group to solving this problem. And a student coming here could hear what Bob has to say about the problem.
Alright, so my name is Bob and I'm going to be the first one in the class to take a crack at this flashlight problem. The first thing that I'm going to do is to plot my points.
So Bob is using my applet that I created for the problem.
Great. Now that the points are there, I think I'll make the scale a little bit more user-friendly. Of x equals x squared.
So Bob is trying the parabola f of x equals x squared.
Alright, so that gave me a parabola, which I think might be the answer that I'm looking for. But as you can see, that parabola doesn't cover very many of my points. It only hits one. So let's try another equation here. Hit more points. So I'm going to just try a few more six, but I think it can still be better. I'm not exactly sure where to go from here, so I think I'll pass it off to my classmate.
So Bob has started the initial exploration of this problem, suggesting that maybe a parabola would be an appropriate model. And he's left at this point here, but he's also, as well as posting the video, has posted his GeoGebra applet. And as I said, this is a live applet, so if a student clicks on it, they're able to do something. For instance, I would be able to introduce a different question. Let's say I want to try out x squared minus 8 as the possible parabola, which obviously is not correct, but I'm able to actually interact with Bob's applet as the solution as he left it. And that's what Mary has done in creating her solution and adding with a screencast ideas to add to Bob's, and again a further advancement on the solution to the problem. We've been using this, testing it out in various classrooms. In particular, this past year, I've had the opportunity to work quite extensively with a teacher in Ontario here, Jill Lazarus, in a grade 10 classroom. And what we found is that the technology, in fact, works fine. We do have some problems, though, and our problems are more in the human dimension of two types. One, despite the regular newspaper reports about the net generation, the students do lack a lot of web skills. They do know how to use Facebook, etc., but really how to work with something more complex like a wiki, and how to do the screen recording and posting the screen recordings, is something that they have not done a lot of, and so it takes considerable time to coach them in that. More importantly, despite the fact that Ms. Lazarus has, in her classroom, done a lot of collaborative problem solving in a face-to-face manner, students are still reluctant to contribute ideas that they are only tentative. You know, they're beginning initial ideas in a problem, and so they need a lot of encouragement to get the discussion going. A lot of work with the teacher, saying to them, you know, that's a good idea. You know, why don't you put it up there? I know it's not, you're not finished, but let's get, you know, why don't you give it out to put it up on the web so that your classmates can build on that. So we have a tool which is very supportive in the technical aspect of mathematics collaboration, but we certainly need to do a lot of work on the human dimension.